In this example, we are going to be using some elementary row operations and elementary column operations to assist us with evaluating the determinant of this 4 by 4 matrix. So, first row of this 4 by 4 is 0, -4, 9, 3. Second row is 9, 2, -2, 7. Third row is -5, 7, 0, 11. And the fourth row is -8, 0, 0, 16. Now, I do see a couple of rows and a couple of columns that contain 2 zeros. I would like to start by getting fixated on those. So we could either take a look at the third column, which already has 2 zeros in it, or we could take a look at the fourth row. Now, I do see something extra about the fourth row, which is that they have a factor in common. The 8, 0, 0, and 16, we could pull out a common factor of 8 from that row. Or I guess we could do -8 as well. It's not going to make that big a difference. So we'll pull out a +8 from the fourth row and have that fourth row become -1, 0, 0, 2. Everything else will stay exactly the same. 2, -2, 7, and a 0, -4, a 9, and a 3. Now, using that -1, what I could do is start performing some elementary row operations to start zeroing out the entries that are above it. Instead, I'd like to introduce an elementary column operation. Now, this is only advisable during determinants, but what I'm going to do is I'm going to take 2 times the first column, I'm going to add that to the last column to have that become the new last column. So we wind up with 8 times. First column overall is staying the same, 0, 9, -5, -1. Second column stays the same, -4, 2, 7, 0. Third column stays the same, 9, -2, 0, and 0. However, I'm going to be doubling the first column and adding it to the fourth column. So 2 times 0, add to 3. 2 times 9, add to 7. Oh boy. 2 times -5, add to 11. That's nice. And then 2 times -1, add to 2. Now, the reason I did that is because if we now take a look at our fourth row, we have 1 non-zero entry, and the rest of the entries are all 0. So what I'd like to do is do a cofactor expansion. And we'll be using the fourth row. That way the only non-zero entry that we'll get is from A14. So this will be 8 times A14 times the 1,4 cofactor, plus everything else in here is going to wind up being 0. So we'll just refer to that as a lot of 0. Now, because of its relative location in this square matrix, the 1,4 entry, that's plus, minus, plus, minus, we account for this with a negative. However, the entry that we have there is -1, so that's super convenient. And then we'll be multiplying this by the associated minor that we get by eliminating the first column and the fourth row. So it'll be -4, 9, 3, 2, -2, 25, 7, 0, and 1. I'm going to pretty this up just a little bit. Pretty this up, and we'll call that +8 times this 3 by 3 determinant. So -4, 9, 3, 2, -2, 25, and 7, 0, and 1. Honestly, if we wanted to do a cofactor expansion down the third row, or across the third row right now, probably wouldn't be that bad. But I am going to do one more elementary column operation. I'm going to take -7 times the third column, and I'm going to add that to the first column. Column is spelled with C. Professor Friday, come on now. Sorry, force the habit. The idea is we'll be using this 1 that we have in the 3-3 entry to zero out the entry that we have in the 3-1 entry. So second column is staying the same. Third column is staying the same. And oh boy, this is going to get weird real quick. So negative 7 times 3, add to negative 4, we'll get negative 25. Negative 7 times 25, add to 2, that's going to be negative 173. This may not have been as advisable as I might have thought. And we'll get a 0 here. Now we can do a cofactor expansion. Using the third row. What we'll wind up getting here is 8 times. We'll have the 3, entry times the 3, cofactor, and then the other two terms that we'll get will both have zeros associated with them, so we'll get a lot more 0. So we'll have 8 times. For the 3, entry, we start with a positive, minus positive, minus positive. That's a positive position, so that'll be simply 1 times the 3 minor, which will be negative 25, 9, negative 173, and negative 2. I was really hoping to do this without turning to a calculator, and you know what? I'm sticking with it. This will be 8 times the 2 by 2 determinant, negative 25 times negative 2, negative 25 times negative 2, minus 9 times negative 173. So that'll be 8 times 50. Let's see, minus a negative, that'll be plus. And there's absolutely no way that I'm planning on turning to a calculator for this. Well, obviously this is 1,557, which I totally got without using a calculator. Continuing to simplify, this will be 8 times. 50 added in there will give us 1,607. 8 times 16 is 128, and 8 times 7 is 56. Final answer for this one will be 12,856. And if you had to turn to a calculator at some point in here, absolutely nobody blames you.